Okay, so we are going to be looking at our inverse trig functions, and we're going to be looking at differentiation first. And so, again, I said this, but it's all prerequisite knowledge. You're supposed to remember your inverse trig from your trig class, but I'm going to go over just these examples A, B, and C really quick, just evaluating them so you remember how to do it. All right, so again, make sure that you know where the inverse trig functions are defined. All right, so when I look at this first one, I want to evaluate arc sine of a negative 1/2. Now, when I do these, I use triangles because that's the way I was taught. That's the way I learned. You might have used the unit circle or a chart method, anything like that, but I'm going to do triangles because that's the way I know. All right, so A is evaluate arc sine negative 1/2. So this means, all right, we want the angle whose sine is negative 1/2. So the first thing I do when I think about it is think about, all right, where is arc sine, where is it defined? And I know it's in the first and fourth quadrants, so I'm going to mark out the second and third quadrants. All right, so I want the angle whose sine is a negative 1/2. So I'm deciding if I'm in the first quadrant or the fourth quadrant to draw my triangle. And so you're looking at, all right, well, in which two of those quadrants is sine going to be negative? And so you know it's negative in the fourth quadrant because all trig words are positive in the first quadrant. So if I look at and draw my triangle there and fill in the legs, sine is opposite over hypotenuse. So those would be the legs of my triangle, which is the 1, 2, square root of 3 triangle. And so then you would ask yourself, which angle is across from, the 1 is across from what angle, and so you know that's at 30 degrees. This is your 30, 60, 90 triangle, so you want the 30 degrees down there. Now what you can't do is give me, and go all the way around and give me 11 pi over 6, because arc sine is only in between negative pi over 2 and positive pi over 2. So you can't give me 11 pi over 6 because that isn't in there. So you have to give me negative pi over 6. Okay. Alright, so keeping on with our next example, we've got arc cosine 0, and so remember this is just another way to write it, but it means the same thing. So again, I would think about, alright, where is arc cosine defined? And it's in the first and second quadrant, okay? And so I would think about where to draw it. Now you can use this right here, but whenever I see a 0 or a 1, I go to the graph instead. I don't think about drawing the triangle. Alright, so whenever I see that 0, I'm going to think about the cosine graph. Alright, so cosine graph looks like this, and you know cosine is between, arc cosine is between 0 and pi. So if I think about it, this is 0, this is pi over 2, and here's pi. So I'm going to shut it off right there, and I'm looking at just here. So you want the angle whose cosine is 0. So if you're looking at this little section of your graph, where's your cosine 0? Well, it's right here. That's where it crosses. What is that right there? That is pi over 2. Okay. And then finally, I want arc tan of square root of 3, and remember you can also look at it if you're doing triangles, it would be square root of 3 over 1. So let's see where arc tan is defined, and it is in the, just like arc sine, the first and fourth quadrants. And so where is tangent going to be positive out of these two? It's going to be in the first quadrant. So if I fill in the legs of the triangle, tangent is opposite over adjacent, and so that again, that's that 30, 60, 90 triangle. Which angle is across from the square root of 3? The square root of 3 is across from which angle? And so you know that is 60 degrees, so that's the pi over 3. Okay. Alright, so definitely make sure you remember your trig from, or your inverse trig from your trig class. Alright, so moving on, derivatives. Derivatives of inverse functions. Second half of this class is a ton of memorization. Some of it will be given to you, but some of it I expect you to memorize. This is something you need to memorize. Make sure you know all these formulas for the derivative of the inverse trig functions. You really only have to memorize 3 of them, because if you notice, the 3 on this side are just the negative of the 3 on this side. Okay, so make sure you memorize those. All right. I don't think I have enough room to work right underneath it, so I'll do my best and work over here. Alright, so D says I want y equals arc sine 2x, and I want that derivative. So we're going to use this derivative, that derivative formula right there, which is u prime over the square root of 1 minus u squared. So let's think about what these pieces are. Well, u is just 2x, okay? So that makes u prime the derivative of that, which would be 2, and we also need u squared. So if you squared that 2x, you get 4x squared. Okay, so those are the pieces that we need so we can plug into our derivative formula. Super easy. It is u prime on top, which is 2, over the square root of 1 minus u squared, which we said is 4x squared. Okay, super easy as long as you know your formulas. Alright, let's move on. E. Okay, y equals arctan 3x, so very similar to that first one. Now we're going to be using the arctan derivative formula, which is u prime over 1 plus u squared. So again, this one u would be 3x, so u prime would be 3, and u squared would be square 3x, you get 9x squared. So we can plug into our formula. U prime on top over 1 plus u squared on bottom. Now those two were pretty basic. F is also not very bad. Let's see, how am I going to do this? Okay, so let me arc secant e to the 2x. So that was F. Alright. Arc secant of e to the 2x. Okay. Alright, so we're going to need this arc secant formula, which is u prime over the absolute value of u times the square root of u squared minus 1. Alright, so let's do that. So on this one we've got u, which is e to the 2x. So u prime would be, remember we've already done this, derivatives of e's, copy your problem down exactly, times the derivative of the exponent. So I'm going to write that 2 in front. Alright, now I want to do u squared. So what I've got to do is take this e to the 2x and square it. And remember from algebra, when you want to raise a power to a power, all you're doing is multiplying those exponents. So u squared is e to the 4x. Okay. Alright, so remember your formula for the derivative of arc secant is u prime over the absolute value of u times the square root of u squared minus 1. So we'll plug into that. So u prime on top, which is 2e to the 2x over the absolute value of u. That's the square root of u squared minus 1. Now you can do a little bit of simplification here. Right? This e to the 2x, it's going to wipe out. Okay? And so then, get back to my green. Okay, your answer would be, your derivative would be a 2 on the top and square root of e to the 4x minus 1 on the bottom. Okay. Alright, and then let's do next one. Here we go. Let's do G. Hold on. Erase that. Okay. Y equals, alright, natural log of t squared plus 4, okay, minus 1/2 arctan of t over 2. Okay, so we've got two separate functions, so we're going to have do these derivatives two separate ways. Alright, so derivative of a natural log. We've done this. You draw me a fraction bar. Whatever's behind the ln goes on the bottom. Derivative of the bottom on top. Okay, and I'm going to leave this one half. Alright, so arctan, we need a u, alright, which is t over 2. I prefer, this is just personal preference, to write it as 1/2 t. Okay, so then we need u prime, which is just a half, and we would need u squared. So if you squared 1/2 t, you get 1/4 t squared. Okay, so your arctan formula, remember you're going to have it memorized, is right here, u prime over 1 plus u squared. Alright, so let's fill that in. So we would have u prime over 1 plus u squared. Okay, now watch what happens. Alright, I'm going to do a little bit of simplification on this one as well. So nothing I can do with this fraction. Okay, but what I'm going to do is multiply the 1/2 times the 1/2. Okay, so I'm going to get my 1/4 times now that. What I want you to do is, what would you get if you distributed that 1/4 through there? Okay, so this one is the same. Minus, you would get 1 over, alright, multiply that 4 through, and we would get 4. Right, plus, alright, what happens when you do the 4 times the 1/4? Well, they're going to cancel out, and you just get 1 t squared. Now look at your two fractions. You can add and subtract fractions if they have the same denominator, and these two do. Now they're out of order, but t squared plus 4 and 4 plus t squared, they're the exact same thing. So I can go ahead and put that together, 2t minus 1, and just keep that same denominator, t squared plus 4. So there is my derivative. And we've got one last one to do. Let's do that one. This is h. Y equals x squared arctan of 5x. Okay. Alright, so we just used that arctan formula, so hopefully we'll remember it. Now, notice this is an x squared times an arctan. You've got a function times a function, so we're going to have to do a product rule from calculus 1, where we do the 1d2 plus 2d1 to get our derivative. Okay, so we need 1d2, so there's 1. Alright, d2. Alright, to get that derivative of that arctan, we'll go u is 5x, so u prime would be 5, and u squared would be 25x squared. Okay, so the derivative of the arctan formula, remember it is u prime over 1 plus u squared, so u prime over 1 plus u squared. Okay, so there's 1 d2, that's 1, and that's d2, plus, now I need 2 d1, so 2 is arctan 5x, and then d1 is just the derivative of x squared. There's not a ton of simplification on this one. All I can really do is multiply the x squared and the 5. Okay, so I would get 5x squared over 1 plus 25x squared plus, now remember it's super bad if you try to mix that 5x and that 2x and multiply them together. You cannot, because that's arctan 5x. You cannot multiply that 2x in there, so just write it on the front. And there you go. There is your derivative.